So my name is Maffrezzoli. I'm Sales and Business Development Manager at Zafiro. Thank you for the introduction. My experience is in energy. I've been in energy since the beginning of my career, but in different energies. Oil and gas at the beginning, hydrogen and fuel cells, and now in power systems. Before starting, a few words about Zafiro. Zafiro is a Swiss company. We're based in Lausanne. And we develop a platform, a software for medium voltage or distribution grids to provide observability and fault location and detection. So some basics about synchrophasors for those of you who are not familiar with the technology. Synchrophasors are compressed representation of amplitude, phase, angle, and frequency of an AC waveform. When these measurements are synchronized with time, we call them synchrophasors. So just to give you a brief idea of what is the difference between PMU measurements. So PMU are Phasor Measurement Units that measures phasors versus SCADA measurement. So SCADA measurement, we have measurement of voltages and current and only amplitude, and the measurements are taken every few seconds or even minutes, with a time synchronization that when it's present is with an accuracy of less than 1 second. In case of PMUs, we measure voltage and current phasors, with a measurement that are taken every 20 milliseconds and with a time synchronization that is very precise, so less than 1 microsecond. The result is a better observability of the grid, so more awareness of what is happening in the grid, and we can also detect transient, which enables us to also check power quality events and incipient faults in the grid. So what are the typical distribution SCADA implementation, the challenges of the SCADA implementation in distribution grids? In general, is the system complexity. So large investment, a lot of data availability, limited grid instrumentation, and when this grid instrumentation is present, is very diversified. And how PMU can help to solve this challenge. So the idea of PMU is to have few measurement devices installed in critical points of the grid that provide and that solve different use cases. This is really the advantage of PMU technology and of a platform that can use PMU measurement, is really to serve different kind of use cases and different departments in the same company. But I will go through it in a while. Something more precise about what we offer at Zafiro. At Zafiro, we offer a solution that is called SynchroGuard, that is a platform that enables observability of the grid in real time with measurement, as I said, taken every 20 milliseconds, outage management, corrective maintenance, so information about faults, fault location, and also preventive and predictive maintenance based on incipient fault and on the capability of PMU to check everything that is happening in real time in the grid. And as I said, power quality events in general. We offer a solution that is an integrated solution, hardware and software. Something that I want to highlight, we are a software provider, we are a solution provider. We also have the hardware that is an enabler for this solution to work. So how does it work? Physically, we integrate one PMU in the primary substation, so high voltage to medium voltage substation, where we measure current and voltages. Voltages through conventional VTs that are available in the primary substation, and currents through Rogowski coils, so non-invasive installation. Then, based on the single line diagram and the topology, we select some critical points in the medium voltage to low voltage substation, and we install PMU only in these critical points. In general, with a coverage between 10 and 20%, we are able to get observability in all the grid, which means that we take measurement in 1 out of 5 to 10 substations. And thanks to the time synchronization and to the precise measurement and our algorithm, we are able to estimate the transformer loading and line loading everywhere, so in all the substations. So as I said before, one PMU in the primary substation measuring current and voltage, and some PMU installed in critical points only measuring currents. We have flexibility on the deployment, so we can deploy it both on cloud and on-premise. In general, what we do is for pilot project, we deploy in cloud, and then for deployment, we prefer on-premise solution. So what it gives, SynchroGuard is a platform that can help operation people, so control room operators, planning, managers, asset managers to plan the grid. It really solves different use cases. We have mainly 4 modules. The first module is the observability module. So through state estimation, we provide observability in all the grid in real time. So we can integrate renewables, check congestions, so on and so forth. And then outage management. This is the other important module that we have. We basically provide fault detection and fault location, so helping corrective maintenance and reducing the intervention time, so SCADA and SCIFI. And we provide also information about power quality. And thanks to this module of power quality, we are also enabling a 4th module that is the one on predictive maintenance. So basically, based on power quality events, we can extend the lifetime of the assets and also calculate some time to failure for the equipment. Now, this is the most interesting part, I think, because this is a real examples of what we have done. I will show you first an example of a client that was interested in observability. This is a German client. Here we have 1 high voltage to medium voltage substation, so 1 primary substation, 2 feeders with a total of 80 secondary substations. In this case, the interest was the integration, or rather the management of renewables, because the client was totally blind about what was happening in the grid. So our solution was to deploy 1 PMU in the primary substation and 6 PMUs in some selected critical points in the secondary substation. So with a total of 7 PMUs, with a coverage that is less than 10%, we could provide visibility in all the grid, thanks to the distribution system state estimation. That is the module that enables the observability of all, of the status of voltage, current, power, so active power and reactive power. So this is what happens. Don't know if you can see, but I will explain you better. So the first graph shows the voltage, and the second one is the current. The blue circles are the measurement, while the red crosses are the estimates. So you can see the first one, we just have a 1 measurement in the primary substation because we measure voltage only in the primary substation. While for the currents, we have more measurement because in the secondary substation, we also measure current. I forgot to mention that we measure current through Rogowski coils, so non-invasive installation. So that's why in the secondary substation, it's really non-invasive because we don't need to measure voltages. As you can see, you get very precise state estimation because they correspond to the measurement. This is a second case, it's a Swiss customer. In this case, the customer was more interested in outages management. The problem was aging of the infrastructure and in general, reliability of the grid in case of extreme weather condition. So in this case, we have 1 feeder. So we install 1 PMU, as always, in the primary substation, measuring current and voltages, and then only 2 PMUs in the rest of the feeder. In this case, we were monitoring approximately 30 medium voltage to low voltage substations, so the coverage, approximately 10% coverage. So this is what happens. I will show you exactly all the steps. I will show you slowly, but in the reality, everything happens in a matter of seconds. So first of all, we have the fault detection. This is what happens in terms of voltage and current. And here you can see the quality of data, so how fast we can detect the measurement and the status. Then we have the faulted area identification, which means that we identify between which PMU the fault is. And then the second step is the fault location. So basically, not only we tell the operator between which PMU, but we also say how far it is. We always say approximately plus minus 100 meters, but in the reality, in this case, was, for example, a 30 meters error. And then there is a fault alarm generation. So the alarm generation can be by SMS, by email, in our dashboard, but this is where it comes, the core of the presentation also integrated with the SCADA system. So the SCADA system gets an alarm, and the operator can easily see between which PMU. So the first thing that can be done is to restore the healthy part of the grid, focus on the part where the fault is, and then send the team to check approximately as we said, at 30 meters from the PMU where the fault is. So in this case is the explanation of how we integrate with Zenon. This is an example of an easy retrofit of where Zenon is already installed. So what we could do is install PMUs in critical point of the grid. So the first thing that we do is to receive a single line diagram with a topology. We select critical points of the grid. We install PMU in the primary and in critical points of the secondary substation, and then we integrate with the SCADA. Integrating with the SCADA can be done at different levels, so we can either send all the information, so real-time visibility, which is generally not totally well accepted because it's too much information and too much data. What we see that is the biggest interest is to have some selected alarms, either on only outages or also some power quality events that are particularly interesting. And then proactively, the control room operator can go and open our dashboard to check in detail what happened. The other important thing of an integration with a SCADA system is that it allows us to receive automatic topology updates, which is something that is needed for our platform to work. So it's really a bi-directional communication on our end to send alarms to the SCADA system and also to receive topology updates. That was my presentation. So if you have questions, I'm happy to answer them. Otherwise, thank you.